Hey everybody, today we're going to talk about the third measure of central tendency, the mode. Once again, a measure of central tendency is some sort of measure that gives us the average, typical, or expected response in a data set. Okay, and we talked about two of these already. The first one was the mean. The mean is the arithmetic average. It takes all of the values of a variable that were observed in a particular data set, and then it adds them all together, then spreads them out evenly across the number of times we saw a value of that variable. And so therefore that gives us the expected value for any given observation of the variable because it averages out across, okay? So it uses mathematics to figure out what the expected result would be. The median is of course just the middle value because it has some advantages over the mean. The mean of course is biased by skewed responses, and the median is not, or at least it's almost not at all affected by biased responses at all. Okay, now we're going to talk about the mode, but I'll contrast it with the other two, as you can see. So the best way to do this, I think, is with a skewed distribution. This happens to be a positively skewed distribution. We'd used it before. Okay, once again, the mean here, as we can see, is skewed by biased response, or not, it's biased by extreme responses, right? So if you have people who have more and more cars, but there are fewer people who have those cars, the more and more farther away they get away from the sort of middle of the data set, which would be roughly here, and by definition it would be the median, the mean starts to get farther and farther away from that by those more extreme scores. So that's an issue. The median is, of course, right in the middle, and it just finds exactly the middle point of the data. Okay, but of course you may notice that there's something missing here, is this peak of the distribution that we haven't mentioned before. Well, that is by definition the mode of the distribution. It's the peak of the histogram if you're using a histogram. However, you could also refer to it by this. The definition of the mode is it's the most frequently occurring score in a data set, or the most frequently occurring value of a data set. So it's very easy to find. The first thing that we do is, just like in the median, we organize the data from lowest to highest. For example, if this were your data set, the data in your kind of research that you do is just going to come in random order, probably, because you can't predict who's going to give you the lower score first and the higher score later. So it comes in some kind of random order, and then to find the mode, it's easiest to then organize the data. So in other words, if you have this data set that came in random order, you put it in an organized fashion from lowest to highest, although it doesn't matter if you put it from highest to lowest, but let's just do that. And by doing this, then you can count the number of times each value occurs, which is step 2. You can say, well, gosh, 2 occurs twice, 3 occurs only once, 4 occurs twice, and so on. And of course, as we can see, the value of 5 shows up more than any other value. Okay, 5 shows up 4 times, and all other values do not occur more than twice. So therefore, in this particular data set, the mode is 5. So that's very simple to do. Now there are some special circumstances where we need to be concerned about the mode. Okay, some data sets don't have a mode, and that's okay, because the definition is that it is the most frequently occurring score in a data set. So you might have a data set, maybe a small one, that just doesn't have anything that repeats at all. So as you can see here, I haven't organized this one from lowest to highest, but it doesn't matter. We can do a quick look here and see that there are no repeating numbers here, and so therefore there is no mode to the data set. So the mode would be useless in this particular data set. In other cases, some data sets have more than one mode. For example, it's not uncommon. Well, I mean, it depends on what you're doing here, but sometimes you'll find a bimodal distribution, or a distribution that has 2 modes, a data set that has more than one mode. For example, these of course I just made up, but let's imagine I have this data set, and a real quick look here shows you that both 43 and 49 appear twice, and there's no other value that occurs more often than that. And so by definition, both 43 and 49 are the modes of this data set. So, and yes, you would refer to this as a bimodal data set, or a bimodal distribution if you were to look at it in a histogram. What that would probably look like is it has 2 peaks, okay? And in fact, in this particular case, they would have 2 peaks that are exactly even with each other because they both occur the same number of times. Okay, and then some data sets may have 3 modes or 4 modes, and that's of course all possible. And of course it is a little unusual, and that's something that you may need to work with in your data set. Now you may wonder, well, how do I know which one to use? Which one is the most appropriate measure of central tendency given my data set? Well, luckily, if your data set is symmetrical, or at least really close to symmetrical, then the mean, median, and mode are all the same, or at least very close to the same. So for example, if you have a perfectly bell-shaped curve, in fact, it doesn't have to be bell-shaped at all, as long as it's symmetrical down that vertical axis, then the mean, median, and mode are all the same. As you can see, the mean is the arithmetic average. It's going to be balanced out if you have the same values on the right as you have on the left of it. The median is going to be the exact middle, and therefore if it's symmetrical, it would be the same. And the peak of the distribution, which is by definition the mode, is also right there in the middle. So if you have a symmetrical distribution, there's no problem. The mean, median, and mode are all perfectly valid and equal. And therefore, our statistics usually just use the mean. However, if there is a skew to the data set, sometimes we have a problem there. It's probably a good idea to report at least the mean and median. However, it may also be a good idea to report the mode as well. Now, you may be concerned about, well, what if I don't know if there's a skew? How do I know if there's a skew or a significant skew? Well, there are some fancy statistical tests that you can do to actually figure that out. It's a little beyond what we're doing here, but that is perfectly possible. For these sort of basic introductory courses, a really easy way to do this is to look at the mean and the median and to see how different they are. If the mean and median are different at all, that means that there is some skew by definition. But how much skew is sort of, it's a little bit subjective at this point, of course. But the more different they are, the more of a skew there is. And so depending on your scale that you're using, you may want to consider that there's some kind of skew there. Now, here's a little guideline also for what direction the skew is. If the mean is larger than the median, that means that it is a positive skew by definition. And again, that's because the mean is stretched farther or higher. Its value increases due to those extreme scores in that positive end of the distribution. Therefore, if the mean is larger than the median, there is a positive skew by definition. If the mean is lower than the median, however, that of course means that there is a negative skew for the same reasons, just the opposite explanation. Okay, so when there's a lot of skew, it's probably a good idea to report all 3. For example, if I were to have this distribution where the mode is significantly lower than the median and the median is significantly lower than the mean and so on, I would probably report all 3 to some interested party. So if somebody were to ask me, hey, what's the number of cars people on average own in the United States? I would probably say, well, the arithmetic average is something like 5.3 or whatever. The median, however, is closer to just below 4, and the mode, in other words, the most common number of cars people own, is something like 1.4 or something. In fact, that's also why you see the average number of children in the United States is 2.3 or whatever it is these days, right? 2.3. They're probably not using the arithmetic average, at least I wouldn't think so. Okay, so just a general summary of what we talked about. The mean, median, and mode give us the average, expected, or even typical score of a data set. And it's very useful. It's a nice way to summarize what's going on with the data and to see a general pattern. They are based on different characteristics of the data set, however. As you noticed, the median is really essentially just focused on maybe 2 values. It's maybe just those 2 middle values, or maybe those 3 middle values, and whatever one is actually in the middle of those 3. So it's really not concerned about the extremeness of any of the other values in the data set. And that's a good thing in many cases, but it also doesn't take into account the extremity. Additionally, the mode is concerned really with almost none of the data. It's concerned only with the most frequently occurring score. And so you lose a lot of information if all you're talking about is the mode. But of course, the weakness of the mean is that it is biased by extreme data. And so is one better than the other? Well, they have pros and cons. I think the trick is to determine which one is most accurate in representing your particular data set. It's very important that if you're trying to understand the skew, you can use the mean and the median to do that. You look at the difference between the mean and median, and if there's a lot of difference, that means there's a lot of skew. If there's very relatively little difference, or if they're the same, then there's little skew or no skew. Now, be careful with this. The reason this is all important is because the more skew you have in a data set, the less accurate the mean is going to be in representing the data. And therefore, that might make it inappropriate. The mean is inappropriate for some measures of statistics, some statistical equations, some statistical tests. So be cautious about that. Make sure that you're upfront with it and try to understand why your data are behaving the way that they are. Okay, that's it for now. We'll come back with more later, and thank you for your time.